Alright, one more problem. Let's look at the Kuta software infinite calculus related rates problem number 6. It says an observer stands 700 feet away from a launch pad to observe a rocket launch. The rocket blasts off and maintains a velocity of 900 feet per second. Assume the scenario can be modeled as a right triangle. How fast is the observer to rocket distance changing when the rocket is 2,400 feet from the ground? So we've got a dude chilling, watching this rocket launch. Rockets have to look awesome because they are rockets. It says that the rocket maintains a velocity of 900 feet per second. So if we call this distance over here the height of the rocket, then dh over dt is equal to 900. That's a positive value. We know it's positive because the rocket's going up. The distance between the rocket and the ground is getting bigger. Okay, the observer is standing 700 feet away. And that value is not changing. It says, how fast is the observer to rocket distance changing? So we're going to call that d. They want us to find dd over dt at the point when the rocket is 2,400 feet from the ground. So that is when h equals 2,400 feet. So again, we needed a relationship that relates h and d, and let's call this value on the ground x. That relationship is going to be the Pythagorean theorem. So we have x squared plus h squared equals d squared. If we take the derivative of that, we have 2x times dx over dt plus 2h times dh over dt, and that's going to equal 2d times dd over dt. Let's see what we know. We know that dh over dt is 900. We know that at this point in time, h is 2,400. We know that x is always 700. So we have 2 times 700 times, well, since x is always 700, dx over dt is 0, plus 2 times 2,400 times 900, not plus, that equals. Now this says 2d times dd over dt. dd over dt is what we're trying to find. Do we know d at this point in time? Well, we can, because we know that this bottom value is 700, and we know that the height is 2,400, so we can use the Pythagorean theorem to help us find what the d is. So we have a little scratch work over here. 700 squared plus 2,400 squared equals d squared. If you solve this, you find that d equals 2,500 at this point in time. So that's 2 times 2,500 times dd over dt. The 2 times 700 times 0 goes away. 2 times 2,400 times 900. That's 432,000 equals 5,000 times dd over dt. If we divide by 5,000, we find that dd over dt is 864. Now remember, we're finding the rate of change between the rocket and the person. So this is measured in feet per second, and that means that the distance between the person and the rocket is changing at 864 feet per second. Excellent.